Earth's magnetic field is one of the planet's most important yet least understood forces. It acts as an invisible shield that protects life from harmful solar radiation. But did you know that Earth's magnetic field also plays a role in influencing global weather? Scientists have been studying the connections between geomagnetic activity and atmospheric conditions for years. The magnetic field interacts with the solar wind, a stream of charged particles from the sun. When these particles reach Earth, they are deflected by the magnetic field, creating the spectacular auroras. However, this interaction doesn't just produce beautiful lights in the sky, it can also impact weather patterns. Solar storms, which are disturbances in the solar wind, can cause fluctuations in Earth's magnetic field. These fluctuations have been linked to changes in atmospheric pressure and circulation patterns. Some researchers believe that geomagnetic storms can influence the jet stream. The jet stream is a fast-moving current of air that helps drive weather systems across the planet. When the magnetic field is disturbed, it can cause shifts in the jet stream's position and strength. This can lead to unusual weather events, such as extreme heat waves or prolonged cold spells. For example, some studies have found correlations between geomagnetic activity and sudden stratospheric warming events. These warming events can disrupt typical weather patterns and even influence the polar vortex. The polar vortex is a large area of low pressure and cold air surrounding the Earth's poles. A disrupted polar vortex can lead to extreme cold outbreaks in mid-latitude regions. The magnetic field also affects cloud formation in subtle but significant ways. Charged particles in the atmosphere can influence cloud condensation processes. When the sun's activity increases, more charged particles enter Earth's atmosphere, potentially affecting cloud cover. Changes in cloud cover can impact the amount of sunlight reaching the surface, altering temperatures. Some scientists propose that geomagnetic activity can indirectly influence precipitation patterns. During periods of high geomagnetic activity, there may be an increase in storm intensity. Hurricanes and typhoons could potentially be affected by these changes in atmospheric dynamics. The ionosphere, a layer of the Earth's atmosphere, is heavily influenced by the magnetic field. This layer plays a crucial role in radio communications and satellite operations. When the ionosphere is disturbed, it can disrupt weather forecasting models. Satellite data, which meteorologists rely on, can experience errors due to geomagnetic fluctuations. Understanding the relationship between the magnetic field and weather is still a developing area of research. Climate scientists are working to incorporate geomagnetic influences into their models. One challenge is distinguishing between natural climate variability and geomagnetic effects. While the magnetic field's influence is subtle, it is thought to be significant over long timescales. The Sun's 11-year solar cycle is closely tied to fluctuations in Earth's magnetic field. During periods of high solar activity, the magnetic field experiences greater disturbances. This can lead to increased storm activity and shifts in atmospheric circulation. Conversely, during solar minimums, the magnetic field is more stable, and weather patterns can become more predictable. Historical records show that major solar storms have coincided with unusual weather events. For example, the Carrington event of 1859 was followed by extreme weather anomalies around the world. Scientists are now using ice core samples to study how past geomagnetic activity influenced climate. By analyzing trapped gases and particles, they can uncover links between solar activity and weather trends. Earth's magnetic field is not static, it is constantly changing and evolving. Over the past century, it has weakened by about 10%, and its north pole is drifting. A weakening magnetic field could have profound effects on global weather systems. Some experts speculate that it might make the planet more susceptible to space weather impacts. If the magnetic field weakens significantly, it could lead to more frequent disruptions in atmospheric circulation. Regions closer to the poles might experience greater weather extremes due to increased exposure to solar particles. Understanding these changes is vital for improving long-term weather and climate predictions. The magnetic field also interacts with Earth's oceans, influencing ocean currents and temperatures. The movement of electrically conductive seawater generates its own magnetic field, known as the geodynamo effect. This interaction between the magnetic field and ocean currents can impact regional climate patterns. El Niño and La Niña events, for example, might be indirectly influenced by geomagnetic variations. The impact of geomagnetic forces on weather is not yet fully understood, but it cannot be ignored. Some researchers believe that monitoring Earth's magnetic activity could provide early warning signs for extreme weather events. Changes in magnetic field strength have been observed before major storms and hurricanes. The ongoing study of geomagnetism and weather will help humanity better prepare for natural disasters. In addition to weather, the magnetic field plays a role in biological processes. Many animals, such as birds and sea turtles, rely on Earth's magnetic field for navigation. When geomagnetic storms occur, these animals can become disoriented, which can indirectly impact ecosystems. Scientists are studying whether these disruptions have any cascading effects on climate. A changing magnetic field could potentially alter migration patterns, which could affect local weather conditions. Geomagnetic influences on agriculture are another area of active research. Some studies suggest that plant growth cycles can be affected by magnetic fluctuations. Farmers might need to consider geomagnetic activity when planting their crops in the future. The correlation between geomagnetic activity and human health is also being explored. Some researchers suggest that fluctuations in the magnetic field could affect blood pressure and sleep patterns. Although this field of study is still in its infancy, it underscores the far-reaching influence of Earth's magnetic forces. The magnetic field is one of nature's most powerful yet invisible forces. It not only shields us from solar radiation but also subtly shapes the world around us. As our understanding of Earth's systems deepens, the role of geomagnetism in weather and climate will become clearer. Scientists are now developing new technologies to better monitor geomagnetic activity. Satellites equipped with magnetometers are providing valuable data on the Earth's changing field. This data can be used to refine weather prediction models and improve disaster preparedness. In the future, understanding the magnetic field could help mitigate the effects of climate change. Earth's interconnected systems remind us that even invisible forces play a critical role in shaping our environment. If you enjoyed learning about Earth's magnetic field and its influence on global weather, follow for more fascinating insights. Nature's complexities never cease to amaze us, and there's always more to discover. Stay curious, stay informed, and continue exploring the wonders of our planet.